All right, welcome back. So in this video, we're going to be talking about how to use functions in Python. So a function is going to be a named sequence of instructions, basically a set of lines of code. We call a function or execute or run a function in order to perform the series of steps that are encoded inside of that function. Effectively, we can call in a function and tell the interpreter to do all those steps together. So for example, we've used the print function to tell the Python to do all of that work requiring actually outputting some content onto the screen. Similarly, we can use something like the len function or length function to get the length of a string. It'll do all the work of like counting how many letters are actually inside a string or not. So if I take the len of hello, that will return 5. So we call a function by writing the name of the function, like print or len, followed by a set of parentheses without any space between them. Don't put spaces between your function name and your parentheses. That's weird style. And then inside the parentheses, we're going to put any arguments that go into that function. What this really means is that if you see parentheses in your code, somewhere, that means that's a function somewhere. All right, let's look at some specific examples. So functions almost always take an argument, which are going to be the inputs into the function. So those are the things that are going to go between the two parentheses. So for example, these are the extra details that explain how this function is going to work. So our print function would take in a string as an argument, and then that tells it what to print, right? So when I run print hello world, the thing that's inside the string, inside the parentheses, is what it actually prints out, right? If I change this to be hello y'all, it actually changes what it does. Functions can take multiple arguments, in which case the arguments are separated by commas. So for example, the print function actually will accept as many arguments as you want to give it. So I could say print hello, but also as a second argument, print world. I put a comma between them, and when I do that, it will print those two arguments with a space separating between them. So I can say print hello world, and also my name, and also the words my name, and they will print all of those things together because I can keep adding these additional arguments as long as I put a comma between them. You can't just put a space between them, the comma has to be there as well. Other functions, like for example, the round function, which rounds numbers, is going to take multiple arguments, but each one is going to mean something different. So at the round function, the first argument is what number I want to round. So in this case, I want to round 5/7, 5 divided by 7. And then the second argument, the one after a comma, is going to say where I want to round to, right? How many decimal places do I want to round to? So this is saying that I want to round 5/7 to 2 decimal places. And when I run that code, it'll give me that result of 0.71, which is 5/7 rounded to exactly 2 decimal places. If we don't put the comma in there, I'm going to get a syntax error, right? Because I've now spoken gibberish. I have not used Python in the correct kind of way. So again, this is a little bit vague syntax error because it just says syntax error, invalid syntax. It just says you made a mistake, but it can't tell us why because the interpreter couldn't even begin to figure out what was wrong with it. But it does tell us where the problem is, and we might see that like, hey, I've got my parentheses, it's a function, but I don't have a comma in there, and hopefully you'll be able to start realizing there's a comma and be able to help identify to figure out where these things might be. The other things to note, all right, so we put our comma back, we're back to working again. The other things to note is that the order of the arguments, the position that they're in, actually matters for a lot of functions. So with the round function, that the first thing we put in is what number to round, and the second one is how many decimal places to round to. If we try to swap these two things around, right, I try to put the 2 first and the 5/7 later, I'm going to run the code and get another error. In this case, I'm going to get a type error, right, which is saying that there's a problem with the types of values that I was using, and it says that the float object cannot be interpreted as an integer. So the only float object in my code, the only float decimal number is this 5/7, and it's saying it's trying to reinterpret that as an integer because it's expecting whole numbers for decimal places, but I've said round 2 to the 5/7 decimal places, and the interpreter doesn't understand that. This is an example of, again, a logical error. Our syntax is technically correct, but our logic, our explanation of what to do is wrong. So the order of arguments is actually defined by the Python language itself, right? The way that function is defined specifies whether we're going to say put the number first or the number of digits first. You can find out what the order of arguments needs to be by looking up the function in something like the official Python documentation. So I have a link here which I'll paste in the comments as well. But you can go to the round documentation and it tells us how to call the function. it says that we can call the function round. The first argument is a number, and the second one is in digits, or number of digits that are left. And actually then tells us sort of how it works and gives some details about the way that function is run. The brackets here are telling us that the number of digits is actually an optional argument. So if you don't specify any number of digits, it'll default to 0. So it'll basically round to like the nearest value of 10. So round to the nearest whole number. Great. Cool. The other thing to note about arguments is that they can, in Python, they can also take what are known as keyword arguments or named arguments. And the way that we do that is we write down the arguments we want to pass, for example, to print, can take in the hello and world arguments. And then we can specify a particular named type of argument, which will be in print might be the sep argument or separator argument. And what that's going to do is that when print prints out the two different words, the sep argument tells us what symbol it should put between them. So by default, it'll print a space between them, but if we want, we can change it to be something like 3 pluses. So that if I print that out, it'll print out hello world with 3 pluses as the separator between those two things. Different kinds of functions will have different sets of keyword arguments. Every different function has a different set of keyword arguments that it may support. You need to sort of look up the function to figure out what kinds of options might be available to it. We're not going to use these a lot, but they do show up periodically and they can be useful, particularly some of the ones supporting around printing to make all those things work. The vast majority, so in addition to taking in some arguments, the vast majority of functions also produce some kind of resulting value. They do what's called returning a value. This is a way of saying that's how they get the output of a function. So a function, what do I want to say? You can think of it a little bit like, we use the word return, it's a little bit like the function goes off, does some work, and then returns. It comes back with the result that you want to use. So for example, the round function returns the rounded number. The len function returns the length of the string. The print function does not return anything, it just prints out some content. It's a little bit different. Good. So the important part here is that you need, if you're going to call a function and you want to have it get that result, and you want to do something with that result, you need to store that result for later, which means that you need to assign it a name so you can refer to it, right? You need to assign it to a variable. So as an example that I have in the slide here is that we can take a value like called the min function, which gets the minimum of any of the arguments, and we can say, let's take the minimum value there, and if I want to use that resulting 0.75, I need to make sure I've assigned it to a value, like a variable, like smallest number, so that I can then do things like multiply by 2, or add it to other numbers, or be able to do other things with this as well. So you need to make sure that you've assigning any functions that you call, that you're going to take that result and assign them to a variable so that you can use them later. If we go to Jupyter, we actually do this work. So if I call this function, this min function, right, and I execute that line of code, Jupyter will, by default, it will output the results of the last line of code in the block. So if the last line of code is calling a function, right, min of 1, 6, 8, 1 of 6 eighths, 4/3, and 5 point plus 9, it will output the 0.75 so I can see what that result is. However, in order to actually use this 0.75 and do something with it, I have to take this result and assign it to some other variable. Once I do that, it will then no longer output the results from that individual cell, but then if I want to actually print out what it is later, I can do so. If I want to use that smallest and multiply it by 2, I can do that kind of work later. So that we need to be able to take those results and save them in a cell for us to be able to use. All right, here's a common gotcha that often trips up people, particularly in sort of some of these earlier exercises and assignments we have been working with. So function names, similar to variable names, can be assigned, have values assigned to them. Effectively, it's possible to use a function name as a variable name, in which case you can no longer use it as a function name later. So let's go back to my min example, right? I can run this code that gives me 0.75, and I might say, hey, I want to save that value. I want to be able to use it later, so I'm going to assign it to a variable, and it's a minimum, so I'm going to go ahead and assign it to a variable called min. And once I do that, that runs just fine. I can go ahead and print out the min, and there's my 0.75, and life is great. Except the problem then being, if I pull up some other code, if I say I want to then take the minimum of another set of numbers, for example, I want to take the minimum of 8675309, then I can, when I try to run that code, now I'm going to actually get an error. And the error now is that my float object, it's another type error, it's a logical error, right? My code is readable, just it's nonsensical. It says my float object is not callable. Because what min is, right, I printed out, min is 0.75. So I effectively tried to just write I tried to write 0.75 with parentheses after it, and that doesn't work. 0.75 isn't a function. I can't call it. So what this ends up meaning is that effectively I've lost the ability to use the min function because I assign it to a variable, so it's gone and it doesn't exist anymore. That's a problem generally. If you want to fix this problem, if you go to the kernel menu, you can restart your kernel. That will get rid of all the variable declarations that you've made. It won't delete your code, but gets rid of the declaration so that you can be able to then reassign your result to something that's not the name of a function. So I'm going to restart my result. Instead of calling it min, I'm going to maybe try minimum. See better? Minimum. I can't spell. So then now I can save that to minimum. I can print out my minimum, and now I can go ahead and run my min function again, and it continues working, and 0 is the smallest of those numbers. So yeah, this is a common kind of issue. The common words you're often going to need to avoid, because they're also function names, are things like min, max, sum is a function. I tend to use the word total instead of sum because sum is already used. There's a bunch of these things as well. You can actually see a list of the built-in functions in the Python documentation. And again, I'll put this in a comment of the video. That there's only a small list of these sort of functions you have to avoid, but there's a couple common words, right? Sum, min, max. Those are the ones we want to try to avoid. So it's not that long a list, and in general, Jupyter is pretty good at highlighting stuff with green. If it makes the variable name look green, right? Like when I tried doing min is equal to 3. If it makes that variable name look green, that means it's a keyword, and we shouldn't be using that as a variable name. Come up with a different word, pick something else you'll be able to use. All right, so this is a list of functions that are in Python, but this is not the only list of functions that might be used. Each type of data, so strings, numbers, floats, ints, etc., they all also support their own set of what are called methods, which are functions that you can call on the variable. So rather than taking a person variable and passing it into a say hello function as an argument, I could instead basically tell that person variable to say, hey person, go do your say helloing thing, and then the person would in fact say hello to somebody else. So the way that we do this, the way that we use these methods, which is really just another name for function, is that we're going to call them using what's known as dot notation. So we do that by putting the name of the variable that we want to do the work, followed by a dot, a period, and then followed by the name of the function or the name of the method that we want to call. So for example, if I have a string that's message, and this is a string, I'm assigning a string to it, I can take that string, message, and I can put a dot, and then tell that string to do its lower method, to say, hey string, make a lowercase version of yourself. Similarly, I can take my message and tell my message to then replace itself, to do a replacement function, say, hey string, make a version of yourself that replaces the word hello with the word howdy. So the dot in programming reads a lot like an apostrophe S, a possessive in English, right? So when I say message dot lower, what I'm really saying is call messages lower method. I'm saying call messages replace method. And that'll let me then be able to specify what are these kinds of things we want to do. You can find a full list of all of these functions, of all the methods the data type supports inside of the Python documentation. So for example, here is a list of the string methods. So these are things that we can do on top of strings. So these include things like capitalize, caseful, center, count, and code. There's a whole bunch of this thing, and this list goes on for a while, and it tells you how to call, what these functions are and how to call them, and even gives you examples for how to use them as you go. The thing to note about reading this documentation is that when it says str.capitalize, the str is not something you type. You don't actually type the letters str. What you're going to do is you're going to put your string there instead. So I would put message.capitalize in order to actually execute this code. So here, let me do an example. So look, there's an example. So for example, I can find my message, hello world, and I can print out the message. I can then call message.capitalize, and then that will give me the capitalized version of this message, right? It's going to take the H and capitalize the front thing. Capitalize doesn't actually find the individual, like it doesn't use space and treat spaces, it's just going to capitalize the first piece of the word. We can use a slightly better example maybe if we use like upper, it's a little bit more noticeable. All right, this is going to make it uppercase. Great. The important thing to note though about these string methods is that the string text itself, right, this guy is actually immutable. It cannot be changed. It's just like numbers, right? If I take 4 and add 1 to it, I get the result 5, but I'm not actually changing the value of 4, right? 4 still means 4, it's just that I'm now producing a new number that's 4 plus 1. Strings work the same way. So when I call a method on a string, I'm not actually modifying that string. What I'm doing is instead producing a new string that is that previous string with some transformation applied to it. So if I say call message.upper and then I try to print out the message again, right, you'll notice that my message is originally lowercase version. I'm then saying, hey message, make me an uppercase version of yourself, which it does. But that uppercase version of itself, I'm not doing anything with. I don't give it a name so that when I print out message the second time, it's still lowercase because it's the same string. I've never changed that message string. So if what I want to do is to take this function, this method, and use that return value and assign it to a variable so I can use later, right? I might make my message uppercase, and then I could print out my message uppercase as being something different. That's bigger. Or if I really do want the message variable to now refer to an uppercase version of itself, I could simply update that particular variable. I could say, let's take the message upper, assign that result to the uppercase version of itself to that name tag, right? Go take the name tag, move it to the uppercase version, and then when I print out the message result at the end, I'll now get my capitalized hello world. So I'm now shouting the thing that I want to shout. So this in effect will let you change the variable, but you have to actually do that assignment in order to get the variable to actually change. But wait, in addition to data functions, there are actually data methods. There are even more functions you can use. There are hundreds of other functions, thousands of other functions. There are more functions than you could ever even think about. Functions of every shape and size and color, and actually not colors, they're just shapes and sizes. So Python organizes these functions that exist in the world into what are referred to as modules. You can think of a module a little bit like a box of functions. These functions are not available for use by default, right? The box is like in storage, it's somewhere else. We can't normally just get to it. And it does this, normally they're sort of unavailable by default because that way the interpreter can be faster about finding the functions it needs to use, right? It doesn't have to go through every different box, it just has those boxes to be used elsewhere. If it doesn't have to load them all into your computer's memory, into your computer's RAM. But that said, you're allowed to get out these boxes and use their functions and make them relevant later. So you can get out the box, you can basically access a module, get access to its functions by using a keyword called import. So if I write some code and I say import math, then what that's going to do is that's going to get the math module, the math box, which is a box that contains a bunch of math functions, and that's going to load it into memory and make it available for me to use. Which means that I can then call, for example, the math.sqrt or squirt or square root function, which is part of that module from that box, in order to be able to say, get the square root of 25, which is 5 if you remember the math. Because once we've loaded up the box, I can use the dot notation, right, this dot, in order to be able to refer to a function that belongs to that box. Right? I'm going to call the math modules sqrt function. Great. Modules can also contain variables. So for example, the math box also has a pi variable. So I can call math.pi to get a nice value of pi, like that pi. Additionally, if we want to get the math, these boxes contain lots of variables, lots of different functions. If I want to just get a specific function out of the box, rather than trying to get the entire box, I have to always say, go to that box to find this function, go to this module to find that function, I can import a specific function and make that available to me globally without having to refer to what box it came from. I do that by using the from function, by using the from keyword. So I would say from the name of the module, import the function name. So for example, from math, import GCD, or the greatest common denominator function. Once I've done that, I've basically gone to the box, gotten the function out, and put it on the desk so that I can now call that function without having to specify that it came out of the math box. So I don't have to use math.gcd, I can just call the GCD function straight up the way it goes. This is going to mean that, you never need to put things back in the box, right? This is a metaphor, just loading them into memory. But that way you can basically choose, do I want to get all the modules and then be able to just refer to them as part of that module, right? All the functions part of the module. Do I want to get individual sets of functions? Do I want to get a couple of functions? Do I want to get everything? There's a couple of different options we have to how to make this all work. So the math module is built into Python. It's like a box that comes with Python. Other modules are going to need to be installed separately. Luckily, the Anaconda system that you had installed when you installed Python actually comes with a whole bunch of other common modules that are used frequently in data science. So almost every, and not almost, every other module we're going to use in this class is either built into Python, so you just import it without doing any extra work, or it came with Anaconda, so you just import it without doing any extra work. You're not going to have to deal with trying to fight through installation issues in this class, but that is a thing that occasionally you may have to do that way in your future career somewhere. So we'll just be importing the modules and the functions that we need, and then be able to be good to go from there. And that about covers how to call functions. It's worth noting that you really don't need to memorize all of these functions. You really don't even need to memorize any of them, except maybe print and length. There's like a few functions that are good to know just because you're going to use them a lot, but you'll memorize them because you'll use them a lot. It's better and more important to just be aware of the kinds of functions that exist, right? To have sort of looked through a couple of lists, seen some examples, say from reading the course text or doing the exercises, so that you know the kinds of things that programs can do, and the kinds of functions that are out there, so you don't have to do that work yourself. You can then search for the documentation to pull up the specific names and the argument order and sort of understand exactly how to get that function to work the way you want. Or if you're not sure that a function exists at all, that's also a really great thing to search for on the internet, right? You can just Google like how to do X in Python, and you'll probably find out there's a function that helps you, right? If I want to say, how do I round numbers in Python? I Google rounding in Python, and someone will eventually point out the round function for me to work with. And if there isn't a function out there that you can use that will do what you need, you can always write your own, which is what we're going to talk about next.